Okay, so now we're getting into structures. We talked about it last time. I gave you sort of a general method. I gave you a couple of problems to work on. Today I just want to, I think we're going to spend a while just doing examples. And so today I'm just going to give you a couple examples. We'll see what we get through. And you can work on them. I guess I'll break it up into pieces so we can all sort of check in as we go. But I would love it while you're working on this stuff. If you have questions, ask me, or even better, talk to the people around you, because it helps to sort of talk stuff through. And then in the end, I'll go through it and we'll make sure we're all on the same page. So the first example. You have a pin joint on the wall and a 2-meter long member. And that's supposed to be an equilateral triangle. So all those angles are 60 degrees. This long member has a mass of 50 kilograms. These other two are each 10 kilograms. And there's a cable holding this member up. This angle is 45 degrees. It doesn't look like it though. And then there's an external force of 500 newtons. So just so we're all getting the same answers for everything, it's not going to matter with this one, but let's call this member 1, member 2, and member 3. Okay. And call the joints A, B, C, D. And first, find the Newton's law equations for member 1. So draw that free body diagram, write out that table. Let's all choose the about point to be at A. Just so that we can compare all our numbers directly. Okay, so go ahead and take, so free body diagram looks like this. It's a pin joint at A, so I'll call that RA. It's a pin joint at B. And now since this is between two of those members that we've numbered, this is the force on 1 by 2. And then there's a weight force of 490.5. And then over here, there's a force on 1 by 3. And then also there's that cable. So I guess this is one problem. This is the one spot where it really matters what you choose as your base member. Like I said, I always choose the lowest numbered member at a joint. So I'm going to apply that cable force to body 1, the lowest numbered member at joint C, A, B, C, D. And that force is T. Any questions about that? And our about point is going to be here. Normally you get to choose that, but this is just so we're all on the same page doing this. So now the table, row, force, moment. And I mentioned this to a couple people individually, but you may have noticed that on a lot of the solutions, there are extra columns in this table. I used to do it where like you would start with the coordinates where the force is applied, and then write down the coordinates of your about point, and then you subtract those two, and it gives you the row vector. You can do it that way, but I sort of like it better without. Okay, so I'm going to start with RA. Row vector is 0, 0, 0. Force is RAX, RAY. Cross product is 0. And then F12, the vector from the about point to where that force is applied is 1, 0. The force is F12X, F12Y. And the cross product is F12Y. And then the weak force, that acts at the same point, so the row vector has to be the same. So the row vector is 1, 0. The force is 0, negative 490.5. And the cross product is negative 490.5. And then there's the force F13. The row vector is 2, 0. The force vector is F13X, F13Y. Cross product is 2F13Y. And then the last force is the cable. That's at that same point, so row vector is 2, 0. We need to come up with components for this cable force. It's at 45 degrees, so if this is our coordinate system, here's our vector. So you can see that that unit vector is going to be cosine and sine of 45 degrees multiplied by t. So this is going to be 0.7071 t, 0.7071 t. And cross product is 1.4142 t. And now Newton's laws, Newton's second law. So I'll do the x1 first. So we have RAX plus F12X. Plus F13X. Plus 0.7071 t. Excuse me, is equal to 0. And then the y equation, RAY plus F12Y plus F13Y plus 0.7071 t is equal to positive 490.5. And then the moment equation says F12y plus 2 F13y plus 1.4142t is equal to positive 490.5. Okay, so we have three equations. If we've only come up with three variables so far, we could solve for something now. That can happen, but it almost never does. But let's see where we are with variables. We have this full vector RA, full vector F12, full vector F13, and T. So we already have 7 variables introduced. So we can't solve for anything yet. Any questions about that? Okay, so now let's go, let's isolate member 2 and do the same thing. So I'm going to pause this and you guys go through and calculate this stuff, and then we'll make sure we're doing the same thing. Okay, so free body diagram now of member 2. On the upper left, it makes contact with member 1. So this is the force on 2 by 1. We already have the force on 1 by 2, so we're going to call this negative F12. Then there's a weight force at the midpoint. It's 10 kilograms, so 98.1 newtons. And then down at the bottom, it's a force on member 2 by member 3, so F23. And then the last force is, so that 500 Newton applied force at that bottom right joint. I'm going to apply that to the lower numbered of those 2 members. So we'll put it here, and we won't put it on member 3. So this is 500. Any questions about that? Yeah, so this is member 2, right? And that's where it contacts member 1. So that's the force on 2 by 1, right? That's you know, you could call it F21.
Can you consider the line after inside of B as a middle line, like for the 50 kilograms? Like what we did for 2 and 3. Can we consider that one from B to D as a one line?
No, that's no. This is all one thing. Yeah. Okay, so now the table, rho, force, moment. And for an about point, I guess the easiest place for me would be down here. But so first I'll do F23. The about point is 0, 0. The force is F23x, F23y. Cross is 0. Then the 500 Newton force. Rho vector is 0. The force is negative 500, 0. Cross is 0. Then the 98.1, the weight force. That whole thing has a length of 1. So to get there, it's a distance of 0.5. So it's going to be 0.5 times cosine and sine of 120. So that is negative 0.25, positive 0.433. You can choose a new about point for each member. I did. But yeah, you could keep it the same through the whole thing. Did everyone else choose the same one? I forgot to tell you to choose one. Okay, I'm going to do it your way. If you're going to be that way about it. Okay, so I'll put the about point here instead. But yeah, remember that each new body you choose, it's like a new, you have to use the same coordinate system, but you can use this, you can use a new about point. You can think of each body as like an individual thing that's where you're coming up with 3 equations that are just true. And at the end, you have a system of things that are true, you know? So negative F12, row vector is 0. Force is negative F12x, negative F12y. Cross product is 0. Then the weight force, the row vector is positive 0.25, negative 0.433. The force vector is 0, negative 98.1. And so the cross product is negative 24.715. Is that right? .525.
Well, I actually used A as the about point, so does that work?
Oh, you used, right, this isn't A. Yes, that works too. Okay. Did anyone else use A? Did everyone keep using A? Okay. Right, this isn't A. You're right. So, but I'm not going to do it again. Forget that. But yeah, so like the question is like, A isn't even on this body. Is that okay? Yes, it's just mathematical and that's fine. So F23, the row vector is 0.5, 0.866. The force vector is F23x, F23y. Cross product is 0.5 F23y minus 0.866 F23x. Yes, thank you. And so this is positive. Yes, thank you. That would have messed up every single answer. And then the 500 Newton force, that is the same row vector, 0.5, negative 0.866. The force vector is negative 500, 0. And so the cross product is negative 433. And now Newton's second law says negative F12x plus F23x is equal to positive 500. This is equation 4. Equation 5 is the y component of Newton's second law. So negative F12y plus F23y is equal to positive 98.1. And then the moment equation gives us equation 6, and that says 0.866 F23x plus 0.5 F23y is equal to 457.525. Okay, so now we have 6 equations. Let's see what we have for variables. So from before we had F12, RA first, F12, F13, and T. And now we also have F23. So that's 2, 4, 6, 8, 9 variables. So if this is going to be solvable, we can't add any more variables on the third body because we're only going to have 9 equations to work with. Okay, so now go to body 3. And I guess let's get the same about point this time. Let's put the about point at C. Okay. So draw a free body diagram, come up with the equations for body 3. So, okay, free body diagram of body 3. So down here, this is a contact with body 2. So that's the force on 3 by 2. But we already have 2, 3, so I'm going to call this, I'm going to call it negative F23. And what about that 500 Newton force? Nope, it's not there. It's on the other one. And then 98.1 at the midpoint. And then here, this is contact with 1, so this is F31, so negative F13. And same thing with that cable force. We already applied that to member 1, so we don't apply it here.
Wait, but it is in contact with the tension.
Yeah, but so and the force that cable applies to 1 is going to have an indirect effect on this reaction force. But since we're treating it like it's not touching 3 directly, we don't put it in the free body diagram for 3. So all those things come through in the math indirectly. But in the free body diagram, you're just looking for the things making direct contact with your body. Okay, and the about point is down here. So negative F23, row vector is 0, 0. Force is negative F23x, negative F23y. Cross product is 0. Then the weight force, that is at 0.25, 0.433. That's the row vector. Force vector is 0, negative 981. So cross product is negative 24.525. And then the last one is negative F13. The row vector is 0.5, 0.866. The force vector is negative F13x, negative F13y. Cross product is negative 0.5 F13y plus 0.866 F13x. And so the equations, we've done 6 so far. So equation 7 is the x components of Newton's second law. Negative F, I guess I'm going to change the order a little, but I'm just going through the equation. Negative F13x minus F23x is equal to 0. The y equation says negative F13y minus F23y is equal to positive 98.1. And then the moment equation says 0.866 F13x minus 0.5 F13y is equal to 24.525. So we have 9 equations now. How many variables do we have? Yeah, we didn't add any new ones from the last time. So we should be able to solve this. So this thing needs to have 10 columns. And 9 rows. One, 2, 3, 4, 5, 6, 7, 8, 9. Those are the equations. And then the variables, I'll go RAX, RAY, F12X, F12Y, F13X, F13Y, F23X, F23Y, T, and the constants. Can someone read me the coefficients? Well, you know what? I'm going to do the same thing I did last class. I'm just going to solve this right now and just put it in the document so you can look at the results online and make sure that you're getting the same answers. Does that sound all right to everyone? Okay, so that's the end of class, and I'll get this done and posted in just a second.